Hello everyone and welcome back to a new video. In this video I'm going to talk about effect handlers in Jetpack Compose. As we all know and we all use the medicines to cure a part of our body, we know that when we are taking a medicine, it may have a lot of side effects as well. In programming also we have this. When we are launching a process, it can affect on other part of our devices or our application. That's why we need to control these side effects, and we have to use the effect handlers to control the side effects. In this video, I'm going to choose some of these effect handlers and introduce them to you. Let's get started. For this topic, I have created this program and I've created some composable functions, composable files as examples of these different parts of the effect handlers. But in the channel, we used in some of the applications, some of these effect handlers. So if we had the practical example, I will open that application as well and I will explain there more than here in this application. Okay, let's start with launch effect. This is the first part that I'm going to cover. First of all, I have to mention that all of these effect handlers are like coroutine scopes. Look at here, it's suspend coroutine scope. Actually, the block of this launch effect is a coroutine scope. So it supports the coroutine. So whenever we want to use the coroutine, we have to use the effect handlers. And as you know, the delay in this example is a suspend function. If I take it out, you can see that we have error. And it says it should be executed in the coroutine scope. So whenever you want to use the suspend functions, we have to use the coroutines. And yes, we can use the effect handlers to use this. So what is the launch effect itself? In some of the videos, you see that I'm using the launch effect. Here in the main activity, we have a function called onCreate. And whenever the application opens, anything that we have in block of the onCreate will be executed automatically. So launch effect has an effect similar to onCreate. Whenever we want to launch something, we can write it inside the block of launch effect. And it can have one or more keys. And whenever this key changes, again, anything that you have inside of the block of the launch effect automatically will be re-executed. And when we are using Jetpack Compose, we can say the recomposition happens. Okay, in this case, I have prepared a variable, call it successful call and mutable state of true. So it's a boolean. And I passed it here. We have a delay of 3 seconds. After that, we have a network call. Then we will check if the call was successful. We will display the data. And if the call is not successful, we will toggle this variable. So after toggling the variable, it changes here. So the launch effect will be executed again. We will have again 3 seconds block and the process will be executed again and again and again. Normally we don't write such code, it's just for explaining the launch effect. But let's go to one of the applications that we have created together in this channel to see how we can use the launch effect. I think you remember the memes app that we have created together. If you don't remember it, on the top corner, you can click on the link and watch that video as well. Here I used the side effect. Why? Because I had to use the coroutine scope and we need to use the launch effect. And here I have passed through. It's a constant variable. That means I don't want to relaunch it more and more. So whenever the onCreate is executed, the launch effect also will be executed. And instead of this, even I can pass unit. It's just like void in Java, if you are familiar with Java. So whenever the onCreate creates, the launch effect also will be called. And inside of it, as we know, as we said, is suspend coroutine scope. We can use anything related to coroutine. So that's it, how we can use the launch. And also we had another application, Jetpack. You may remember when we were touching the screen, the Jetpack was recreating. So on that case also I used launch effect, and we can pass a variable here and make the column or the surface of the layout clickable, and by clicking on the surface we can toggle the variable, and by toggling the variable, launch effect will be executed again, and anything that we have here, which is our network call, will be called again. Okay, let's go back and see the next part. When we are talking about side effects and safe coding, we need something like Coroutine Scope. Why? Okay, consider we have a composable function, and inside it we are using this Coroutine Scope, which is the topic of this part. When we are going out of this composition, that means we are closing this composable function. We don't need it anymore. So anything that we have inside of the block of this scope, this coroutine scope, also will be terminated. That's why we use this part. Okay, we have a variable here. Remember, coroutine scope, and then we called it and launched it. And as I said, again, it's like suspend coroutine scope, so we can use whatever related to coroutines or whatever is suspended inside it. And again, as the example, we have a delay here, and after any time we are clicking on a button, the scope will be launched, and inside it we have a delay. After the delay, our process will be executed. But remember that we have to call the scope in callbacks, something like a button, or if you don't have any button, as you can see, let me take it out. We have error here. It says you have to call it in the launch effect, so either in callback of a button or in a launch effect. In the last example, I showed you how we can use launch effect, and inside it we had this scope as well. And let's go back to that example, the practical example. Here you can see that we have this scope and the launch effect, and inside of the launch effect we call this scope. And after launch, as you can see, I've called dispatchers IO to call whatever we have here and connect it to the IO thread, input output thread. For multi-threading as well, we can use this scope. And okay, that was another part of the effect handler. Let's go to the next part. The next part is updated state. When we need to update a state of a variable or something in our application, we can use, remember, updated state, which is another effect handler. Here, consider we have something like a splash screen. We use normally a splash screen to make the network call in the background when the user sees only the logo, we do the network call, we receive the data, and when the splash screen finished and the main screen opened, the user can see the actual data that we received from the server. So we can have a timer for our splash screen, just like this timer, and another timer for our network call or something else. And here I have this composable function, and after we finish this timer, we want to call this. So it's only one timer written here, but consider we have another timer, as I said, for the network call. What happens when this timer finished and that timer finished? You can see only a delay, a double time delay. The timers will be like add together, and it will be just longer, and nothing will change in the state of this on timeout. So what to do in this case? We can pass it to the remember updated state, just like this. And instead of calling on timeout, we can delete it and call update on timeout. So simply we can pass our variable to the remember updated state and check the updated version of it. And that was everything about this. I haven't used this in previous example, so in the future if I use it, I will mention that this is a part of the effect handlers below, and I will refer you to this video as well. Okay, let's go to the next part. The next effect handler that we want to talk about it is disposable effect. I can say it's a reverse of launched effect, but not completely. It has two parts. Again, just like launch effect, we can pass a key here, and whenever the key changes, whatever we have here will be executed, and when we are leaving the composition, we have another function inside it on dispose, and the thing that we have in the lambda block of this on dispose will be executed. So it has two parts. When we are going inside it, one part will be run, and when we are leaving this composition, another part will be run. As a practical example, I have here a media player. When I'm playing a song, here I have a lazy column that has list of my songs. When I'm clicking on one of them, the URI of the song and the context of the application will be loaded in this variable, which is a media player. Then we are starting the looping, and we are starting this menu music, and the song will be played. But when we are pressing back or pressing any other song, it should be released. So we are leaving the composition. So we have to stop the menu music, release it, and load the data of new song on it. And this is a practical example of this. Look at here. I'm clicking on this, and these three lines are executed. Then I'm pressing back, and now on dispose is executed because I left the composition. And as you can see, I passed the unit. That means as soon as we opened this player screen by clicking on this, it should be executed. The disposable effect should be open, and just like that. And if I click on another song, the other song will be played. If you want me to make a video about this media player as well, write down below in the comment section, and I will make it if a lot of you have requests to do this. Okay, that was everything about disposable effect, and okay, I hope you can use it in your applications. Let's go back and see what else we have. The next part is side effect. As I wrote here for you, anything that we have inside this block will be executed after each successful recomposition. So it's so simple, it doesn't take any parameter, and whatever we write here after any successful composition of this composable function will be executed. We can use it as a converter, let's say. Consider we have a boolean here, and or maybe integer or whatever, and it comes from something outside of the composables, like from, let's say, a third-party library or network call, or maybe from normal function, and it's not a state. When we are working with composables, we are talking about states and composition and this family. So if we have a simple variable comes from normal function, we can pass it to a side effect and convert it to a state by this. And again, as you can see, we can use delay or whatever we want here, the suspend function, I mean. So that was everything about side effect. Let's check the next part. This part is about the produce state. Here we had this updated state example, and we had a state and we wanted to update it, so we used this to update it. But here in this case is let's say one part before that. We don't have any state and we want to create a state. It's just like this. We are passing an integer value to this composable function, considering in this case number 5, and it will send a state of integer back as the return to us. Here we have initial value is 0, and we are using this while, and while this value is less than this value, which we consider it 5, after any 2-second delay, this value will be incremented, and finally when it catch the number 5, the threshold, the state will be created and will be passed to the higher level that send this integer to this composable function. And that's it about this part as well. And again, as you can see, we are using the delay inside it, so just the like the other effect handlers is suspend. It can have the suspend functions inside it, and we can use coroutines and whatever we want inside it. Okay, let's go to the next part, which is the final part. The last part of this video is about derived state of. Last week I published video about this animated top bar on the channel. We have here a column. We made it scrollable, and by scrolling it, this top bar will be available or disabled. Okay, here we pass the scroll state value inside of this derived state, and we check if it's equal to 0 or not. Before starting scrolling, the value of it is equal to 0. So this condition is okay, and this is a boolean and it's true. And after scrolling, it will be false. And in this case, we want to monitor this condition, so we use derived state. You may ask why we don't write such code. We can have a boolean, call it a scroll, it's false, and we have if condition. If it's equal to 0, we do something. If it's not, we do something else. it's not dynamic in the first case, just we are using the states and everything inside the Jetpack Compose. And the other thing is that every time that we do have any change, the device, let's say, or the compiler should do all of the calculations from the beginning till the end. In this case, the example is so simple, but consider we have a huge amount of code in this block. So all of the calculations should be done from the beginning. Just like here, we have a value here, and we have a constant part, and we have a dynamic part here. So anytime the compiler should check this and merge these two, and the final version should be loaded inside of this variable. But if we pass this instead of inside of this derived state of the derived state will keep the last version of this, let's say, in the cache, and any part of the application that has access to this can have access to that final version from the cache. And then after any changes, the compiler will just change this part, and this part is remain. So that means low calculation, and by any time we can have the latest changes and the final version of this inside of the cache of this derived state. I hope you understand it, and that's good. That was everything I wanted to cover in this video. If you like it, please give me a thumbs up, and if you are new here, please subscribe to the channel to support me. For those who haven't watched the videos that I was talking about them inside this video, I'm going to put the link of them down below in the description box and in the info on the top. By click on that, you can watch those videos as well. Have a good time. Bye bye.